Hey, welcome back. In this video, I'm just going over some basic introductions to the complex numbers. So if you've never seen a complex number before, basically they look like this. It's going to be something like z is equal to a plus b I. When we talk about a complex number, we're referring to z. Z is the complex number. A and b are real numbers, but a specifically is called the real part of the complex number, and b is called the imaginary part, and the I is called the imaginary unit. And the imaginary unit is defined as I is equal to the square root of -1, which also means that I squared is going to be equal to -1. Now, everything that you know about real numbers is that this can never happen, but the imaginary unit basically was introduced into mathematics to deal with situations where we have the square root of -1. And that happens. There's a lot of applications in engineering where this is going to be the case, and the imaginary unit, or imaginary numbers, allow us to deal with these types of problems. So before we get into that, I guess let's just mention that if we have a complex number that has two parts, the real part and then this imaginary part over here. If b is equal to 0, then the complex number z is just going to be equal to a, so the complex number will just be a real number. And if a equals 0, then z is going to equal bi, so it won't have a real part, and we call that a pure imaginary number. So let's think about an example of a pure imaginary number. It's just a real number times the imaginary unit. So let's say we have 5 times I. We can play with this a little bit, and we can say that this is the same thing as 5 times the square root of -1. We could also say that this is the same thing as the square root of 25 times the square root of 1. And then we could also combine those to say that this is the same thing as the square root of -25. So if you see a value like this in a problem, you know that we're dealing with basically with pure imaginary numbers, or more generally complex numbers. We could work this the opposite way. If you see the square root of a negative value, let's say it's -25 in a problem, you can work backwards. You can say that this is the same thing as, well, the square root of 25 times the square root of -1, which is equal to 5 times the square root of -1, which is equal to 5i. You can kind of go both ways with these things. So something that helps us visualize what's going on with this is we can actually plot complex numbers on what we call the imaginary plane, which basically you just substitute what we would normally consider the x-axis for the real part of the number, and then the y-axis for the imaginary part of the number. So if we had an imaginary number, let's call it z1, and say that it's like 2 plus 5i. Well, we can plot this. We just its real part would be 2, and its imaginary part would be 5. 1, 2, 3, 4, 5. So we could point it there, and if you like having it in vector form, we could draw an arrow out to that as well. Or we could have some cases where like b is 0 or a is 0. So if we had z2 and it was just equal to 2, well, that would just be its real part here. We could plot z2 in the imaginary plane like that. Or if we also had, let's say, z3 with no real part, just an imaginary part, and it was, let's say, 5i, well, we could come on and plot that on here. It would have 0 real part and 5 for its imaginary part, so this would be z3. So what you're seeing here basically is this is looking a lot like vector algebra. And basically with imaginary numbers, we can add them, we can subtract them, we can multiply them, and we can divide them, and we can represent them in a few different ways. And that's going to be the focus of the next couple videos. So join me in those videos and we'll go over all of these different things that we can do with complex numbers.